The video clip you just saw is from the official trailer of the game Dota 2. For this project, we are doing Dota 2 prediction that helps the user predict the winning side with a machine learning model. First, I'll briefly introduce what is Dota 2. Dota 2 is a real-time strategy game with RPG elements. Instead of building armies of units like in classical RTS games, each player controls a single hero, a strategically powerful unit with unique abilities and characteristics which can be improved over the course of the game. In each game of Dota 2, there are two competing teams of 5 players, the Radiant and the Dire. Heroes are the essential element of Dota 2, as the course of the match is dependent on their intervention. During a match, 2 opposing teams select 5 out of 115 heroes that accumulate experience and gold to grow stronger. Most heroes have a distinct role that defines how they affect the battlefield. However, many heroes can perform multiple roles. For this project, we mainly focus on the goal to predict the winning side of a match in Dota 2. We follow the strict pipeline for data analysis, including data collection and cleaning, data exploration, and data visualization. We'll now briefly introduce what we've done for these steps. The Valve company provides a strong web API for developers to fetch both match and player data. For this project, we built a local Python script which calls the Dota 2 web API and save each result into a local file. However, there are a lot of factors that would affect the dataset that we expected. Therefore, we filtered out the invalid and inappropriate data during our collection. The match details we fetched with Web API including every single match generated rather than completed. Therefore, there are quite a lot of matches with absent players, little match duration, or 0 skills and item build. We identify these matches as invalid during our collection process by adding arguments to detect them. In addition to invalid games, we also encountered a lot of private matches and local matches which we have no access to. We also filtered out these matches. For the inappropriate matches, there are currently 23 modes of game in Dota 2. However, not all of them are typical games. For example, only 2 players play against each other in the mid-only mode, which definitely cannot fit into our dataset. In addition, entertaining modes like ability draft or all-random deathmatch can also negatively affect our dataset. Therefore, we identified 7 modes which are the most common and typical game modes in Dota 2, and we believe that they can be used safely to combine into our dataset.
Hi everyone, I'll be talking about the data exploration part of our project. So we used 2 machine learning models. One is logistic regression and the other is neural networks. We chose these 2 models based on prior literature on sports analytics, and we finally decided to go with neural networks because it gives us a higher accuracy on our test data. Next, I will talk about how do we construct our feature vector. So as Sue has already mentioned, there are a total of 115 heroes in Dota 2. However, the index for heroes are actually discontinuous. So the index actually ranges from 1 to 120. And also don't forget the fact that there are 2 sides, either Radiant or Dire in any given match. So taking all that into account, we constructed a vector of size 240, 120 times 2. And the vector is completely binary, meaning that we use 1 to represent the presence of a hero in any given match, and 0 to represent an absence of a hero in any given match. So the first half of the vector, so from index 1 to 120, represents the radiant side, and the second half represents the dire side. So to give you an example, in the first half of the feature vector, if xi, which is each individual element, equals 1, then it means that a player of the radiant side is playing the hero that is at index position I, and 0 otherwise. So similarly, on the second half of the feature vector, if xi equals 1, it means that if a player of the dire side is playing the hero at index position I, and 0 otherwise. Okay, next I'll talk about logistic regression model that we used. So we first randomly split the entire data set into a training data set and a test data set. It is roughly a 70% 30% split, and we were able to achieve a test accuracy of around 59.1%, and we proceeded to validate our results with a 10-fold cross-validation, and we obtained an accuracy of around 59.3%. While this is pretty close to some of the research we have done on the prediction for Dota2 games results, we don't think this is sufficient enough for our prediction purposes. That is why we proceeded to experiment more with neural networks model. So for neural network, we again experimented with different configurations, and found out that the best architecture model for our purposes would be a 3-layer model with 12 neurons on the input layer, 6 neurons on the hidden layer, and 1 neuron on the output layer. And for the input layer and hidden layer, we use the rectifier function as activation function, and on the output layer, we use sigmoid function as the activation function. Now, we chose rectifier function because it has been proven by recent research to be the most effective activation function in deep neural networks, and we use sigmoid function on the output layer just so that it can generate a probability that is easier to map our each training example to either the dire or the radiant class.
This is what you will see when you first click on our website. And we use the official trailer as our background just to make it cooler. Now let's start explore. On the home page, you can read about the brief introduction of Dota 2, including Radiant and Dire, and Dota 2 heroes. At the bottom, there is a Start Prediction button that can direct you to the prediction page. Now, since there are 115 heroes in Dota 2, using a drop-down list to select hero is a really bad choice. Therefore, we made it a simple drag and drop system. You can drag any hero and drop it in the battlefield. And also, you can replace any hero just by a single drag and drop again. Now, after we clicked on the Start Battle button, the JavaScript function will send the hero list to a Python script, which will in turn read the list and predict the winning side using our prediction model. And the results will be sent back to the front end and display over the screen. Now, as we can see here, the Radiant wins with a probability of 66.4%, which turns out to be a really good result. Now, if we replace Puck with Storm Spirit, and let's predict again. Now the Radiant wins with a probability of only 57%. So we also put our documentation under the methods page, including data collection, cleaning, data exploration, and next steps.
So for next steps, there are a few factors that we think should be taken into consideration if we were to improve the accuracy for our prediction. So the first one is that we would love to have more player data. So now we're simply assuming that any individual player can play all the heroes equally well. But in real life, this may not necessarily be the case. A person's performance can easily vary depending on how well this he or she knows the hero that he or she is playing right now. Also, we recognize that the items and skills that belongs to each individual hero plays a very significant role in determining the final results of any given match. So it would be nice to have data on that as well. So the ultimate goal for predicting the final results of a Dota 2 match would be to gamify the entire prediction process. By gamification, we mean that we wanted to be able to predict the match results in real time as the game is happening. And it would be even more interesting if we were be able to somehow be included as a part of the game itself. And this is certainly a very interesting next step for our analysis, and hopefully we'll be able to explore that in the future. Thank you.